All right, so welcome back to our channel. We are doing 6.3, which is called Leapfrog. And this is a lesson that solidifies understanding, which means we're still like laying the groundwork in order for you to practice and apply all the information that you're learning from this unit so far. So the first one, it says, given the pre-image point A located at 2, 6, and the image point A prime located at 6, 2, as shown in the diagram, describe the following transformation, a translation that would carry A onto A prime. So your job for today is going to be, how can I get from here to here, either by a translation, a reflection, or a rotation, or more steps than just one at a time. So how can you get from literally point A to A prime by using a translation? So maybe someone says, oh, Ms. Johnson, we can go down this much and then right this much. Very good. So this would be down 4, right 4. Okay. And so notation wise, this is how we would write it. We would say x comma y maps onto x plus 4 comma y minus 4. And those are like directions, right? Instructions on how to move. Okay. So that's a translation. Interestingly enough, you don't have to use a translation to get from point A to A prime. You can use a reflection. Now, with a reflection, all you would need is the line or the mirror that you're reflecting. So what I like to do is I like to connect these points here like this. And then kind of like see where that middle point is right there. And then kind of draw a line that is like perpendicular to it. So then a reflection, and then you would just say reflect over y equals x. That's the line y equals x. Or whatever line that you would choose to do. Okay, the last one that we would need is a rotation. So I'm just gonna do this. I'm gonna erase this so I have some more points. So the first place that I kind of want to rotate it from is from 0, 0, just because it's an easy place to rotate. And so if you look here, so there's two things you need. You need the center of rotation, which in my case here, I'm using 0, 0. And then you would need an angle of rotation. You would need that angle of rotation. And so for right now, I'm just going to let the angle be the angle for now and not worry about that. And then what I want to do I mean, that's one rotation. I just found a different rotation. You can even rotate it here. Sorry, I was thinking about this. You can even, if I left this, I can even do 180 degrees rotation around this point, 4, 4. So I can do a center of rotation at 4, 4 and 180 degrees, right? It's probably a neat one. I like that one. Another one that you can possibly do that I just saw again is this one right here, because look, it's a 90-degree rotation, right? You can do that one too. Okay. And then if you need two steps for this next one, a sequence of two transformation, there's actually a lot of those answers too. Don't think there's only one answer. Sorry, I'm trying to erase. Okay. So one way to do this is you can, let's see, you can reflect it over, you can have this point reflect over so that it lands here. So then that means I need a reflection over this line, right? So I can reflect it over y equals to 4. That's that line. And then I can translate so that it goes to right 4. So that would look like x plus 4 comma y. Right? So, and then there's a bunch of other ones. You can rotate it. You can rotate it so that it's just short of it and then move it down one, right one. Right? There's not just one answer. So this one says, determine the rigid transformation that carries one image onto another. When given an image and its pre-image, what do I look for to identify a rigid transformation that has already occurred? How do I recognize when a sequence of rigid transformations may be needed to carry one figure onto another? And how do I identify which transformation that sequence might include? And how do I justify that my proposed rigid transformation or sequence of transformation actually works? Okay, so what we're going to do now is we're going to look at this kind of little section right here. And we're going to have to draw our little guy down here. And we're going to try to make a sequence of transformations so that we can get him on from 1 to 2 or from whatever. Like from 1 to 2, like what could we do to get from 1 to 2? Okay. So I'm going to read you the context. It says, Josh is animating a scene in which a troop of frogs is auditioning for an Animal Channel reality show, The Bayou's Got Talent. In this scene, the frogs are demonstrating their leapfrog acrobatics act. Josh has completed a few key images in this segment and now needs to describe the transformations that connect various images in the scenes. For each pre-image image combination listed below, describe the transformation that moves the pre-image to the final image. If you decide the transformation is a rotation, so this is important. If you're saying it's a rotation, you'll need to give the center of rotation, the direction of the rotation, and the measure of the angle. Okay. If you decide the transformation needs a reflection, you will need to give the equation of the line of reflection. If you decide the transformation is a translation, you will need to describe the rise or run between the image points. If you decide that it needs a combination of transformations to get from the pre-image to the final image, describe the transformation and the order in which they need to be completed. So, let's see. So we're going to go from 1 to 2. We're going to start with 1 to 2. From 1 to 2, decide if it's a reflection, a rotation, a translation. Which one is it? Okay, so yes, it is going to be a translation. So here we're going to write the word translation. Okay, and then it says we're going to have to figure out a couple of things. So if it's a translation, we'll have to describe the rise and the run between the two. Okay, so you're going to pick a pretty good point. I'm probably going to use this point right here, which is right under his hand. And I'm going to translate it to this guy, which again is right underneath his hand. I'm going to figure out how much he's going to go up and then how much he's going to go over, right? So let's see, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. Okay. So then I would just say translation up 7 units, and then right 6, was it 6 units? Yeah, 6 units. Shorthand of this would look like this. You take every single point and you do like this, right? I would go +7 on the Y and +6 on the X. Okay. And it's clear to me that it's a translation because look, his like, he doesn't like, he's faced to the same way, right? Okay. So the next one is from 2 to 3. So you're looking at these two and you're saying, how did 2 get to 3? Now, is it a translation? And you're like, no. And is it a reflection? And you're like, no. So I hope it's a rotation because that's all you have left. And you're right, it is a rotation. Can you imagine him rotating, right? And so there's a lot of rotation that you can use. And the easiest rotation that I've tended to find is if it's 180 degrees, right? So I'm going to use that same point under his armpit, which is now right here, right near his mouth and his armpit, right? And then what I do is I connect these dots and I try to find the middle. And it looks like this is the middle. So that's what, 27, 15, 27. And it looks like it's 180 degrees. And I'm just going to put in the clockwise direction. Because remember, for a rotation, it says the center of rotation, the direction, clockwise or counterclockwise, and the measure of the angle. So that's 180 degrees. So we're going to write down here, rotation. I think it was 1527. This is the center. And we're going to go clockwise for 180 degrees. Okay. Now, I'm going to leave you to do number 3. See if you could do from 3 to 4. Okay. And then the next one is from 1 to 5. So 1 to 5, I clearly see a reflection because he's like faced the different way. So you can reflect him now. You can reflect him later. You can even reflect him so that he lands like somewhere over here, right? So I think what I'm going to do is I'm going to reflect him across some line. So I want that point to be here. right? So I'm going to reflect him. And when I'm reflecting him, I need to know where the line is, the middle. So I think I counted 20, wait, let's see, 5, 10, 15, 22. So I got 22, so it's going to be 11. So 4, 9, 10, 11. So this line, I'm going to reflect across this line, so then he lands here, right? And then I'm going to translate him down that many steps. So this line is 17. So I'm going to reflect across y equals to, oops, not y, sorry, x equals to 17. And then boom, he lands there. And then he has to go down 5, 10, 11, 12. And then we're going to translate down, what did I say? 1 to 11, 12. Okay, so with that being said, I'm going to have you explore the example, the image 1 and image 2. Like image 1. Ah, man, I wrote this in the wrong spot. Let me just grab all this. Oh, that's not going to work. Oh, it kind of works. So let me erase the rest of this. Reflect. So I want you to try these other two that we didn't do together, and I'll be right back to go over your takeaways. So the takeaway I wanted to go over with you today was called orientation, and the orientation is determined by the order in which a figure's vertices are labeled. In the diagram, the vertices of the green pentagon are labeled J to K to L to M to N in a clockwise direction. Orientation also means like how it's like sitting. So like look at the orientation of the frog from image 1 to 2. They're faced in the same direction. Versus if you look at from 2 to 3, all of a sudden he does a flip and he's facing in a completely different way. So hopefully this makes sense and now you're able to finish and complete all of your work. Thank you for listening. Have a great day.